Apparently, a long time ago, in a galaxy far, far away, they actually used to have laser swords. No, really, they did. And we forgot how to make them. Kind of like losing the formula to Roman mortar to the Dark Ages.
My name is Eric Strebel. I'm an industrial designer. Welcome to my channel about product design and making. I hope that you like, enjoy, and become a subscriber.
It wasn't until the beginning of the 19th century that we even began to comprehend lasers again. As a matter of fact, Albert Einstein proposed his theory of stimulated emissions. He suggested and theorized that electrons could be stimulated to emit light at a particular wavelength. It wasn't until 1964 at Bell Laboratories when the first CO2 laser was built. And that is when laser model making was born. If you have access to a laser like this, either through your educational institution, local library, makerspace, or you're thinking about buying a laser like this, and you're willing to learn how to create vector files and the software that can control a laser like this, your model making will increase dramatically. I guarantee it. Let's take a look at some laser model making basics with this CO2 50-watt laser.
Did you know that PCBWay has quite the open source section on its website? Check out, for example, this cool Nixie clock. It comes complete with the schematics and the Gerber files that you can modify so you can build it. PCBWay can help you with the PCB and PCB assembly and even PCB design. Check out the link below for more info. I think a good cutting mat, 24 by 36 like this, our Teza one here, is a great place to start for model making, along with some x-acto blades, lots of those, a good x-acto handle, perhaps some tape, and then the different types of glues or adhesives that you're going to need depending upon what type of model making you're actually doing. That's a great place to start. So the first thing that we're going to make is an acrylic 2-inch cube. The reason for this is that lasers are fantastic at cutting acrylic. When it cuts the acrylic, it leaves virtually no mark and a very, very clean cut. I'm using an online resource called MakerCase. It allows you to enter the size of the cube that you want, the material thickness, in this case our 16th inch, which we measured with a caliper to double check. You can then output this file as a DXF file and pull it into your laser cutting software. The software I'm using is called Lightburn. Inside of Lightburn, you can set the power that the laser fires at and the speed at which the head moves. Nothing else is required, no line weight adjustment, etc., etc. You hit start, it sends the file to my laser cutter, and it cuts out the parts. Done. Pretty simple. Granted, there's a few more details, but in general, that's what's required to cut something out on a laser, at least in my situation. You'll notice we left the paper backing on the acrylic, and you want to do that so that if there is any residue left over from the actual cut, it will stick to the paper and not to the material that you're actually cutting. So let's line up the parts. We use a little bit of piece of tape to get things exactly where we want so that when we apply our adhesive, in this case we are using acrylic solvent, and solvent in this case means it actually melts the plastic. So it's not so much a glue as it's softening up the existing acrylic and allowing the two sheets to bond together because they've been softened up at a molecular level so that they adhere to each other. I don't make a lot of models with acrylic, although I do make a lot more now that I have this laser, just because the material is so easy to manipulate and I don't have to cut it by hand and sand it to the right size on the sander. That stuff is all taken care of when you cut the parts out on a laser. We do want to get this box straight and square. We're going to use a right angle tool here, a square, to make sure that it's all nice and straight. The square, by the way, is made by a Japanese company called Shinwa. I get lots of questions about it. So we're going to use a thicker adhesive right here. It's a cement, and that's just a thicker formula of the liquid stuff that I have in the can that I put on with a brush, and we put the top on here, and I basically use that to show you that there are different types of solvents. Check out that rookie mistake. I glued the side with the paper to the box. Yeah, you don't want to do that. Definitely a pretty amateur move right there. All right, let's reapply our glue and glue it on the correct side so the adhesive can actually melt the plastic together and we can make ourselves a good box. Flip the box over and we'll apply some adhesive to the other side. You want to make sure that you have some good wet edges so that the solvent is able to soften up the plastic and actually bond the two pieces together. I'm going to pop a clamp on here and just let that evaporate, maybe for a good 10, 15, 20 minutes. And we got ourselves a very nice, shiny, square acrylic cube. One of the other materials that the laser cuts pretty well is wood. And I'm going to make a 2-inch cube out of some basswood. This is different than balsa wood. So basswood is not as porous as balsa, much better suited for model making. We're going to use the same online resource, the Maker Case website, put in the same exterior dimensions, and we'll just change the thickness of the material here, and that will give us our file, and we'll pull that into our Lightburn software, and then we'll cut that out on the laser. You'll see there's a little bit more smoke from the wood here as it kind of burns through the wood. Now, I did not put any tape down, and that was a little bit of a mistake here. You want to put some tape down. I'm using some Blue Painter's tape, and I'm showing this as an example here. So any residue from cutting or smoke will get stuck to the tape and not to the wood. And a lot of times people use what's called a transfer tape. It's what the sign painters use when they use transfer vinyl lettering onto a vehicle. If you do get some of this residue from the burn on your wood, you can use a little bit of denatured alcohol to clean off this residue and kind of clean up your parts. But better to use some tape or something to prevent that soot from gathering on your wood in the first place. We're going to put the box together just like we did the acrylic one with some painter's tape and lay that all out. We're going to use super glue, acrylate, to glue this together. And the reason for this is not that we couldn't use like a wood glue or a carpenter's glue. It's the acrylate dries much, much quicker. And when you're building models, you don't want to wait too long for your glue to dry. I'm using what's called a kicker or an accelerant to accelerate the acrylate and cause it to get hard faster. This accelerant causes the acrylate or the super glue to gel up almost instantly. If you do have a gap where you feel you don't got a good connection, you can lay in a little bead of super glue here and then come back and you can hit it with some of that accelerant, kind of like if you were caulking a corner. This will give you some additional strength. So let's put the ends of the box on, and I spray a little accelerant onto the wood first, and pretty much as soon as that comes in contact with the glue that I've laid down on the edges, it will cure. Again, we'll do the same thing on the other side. You don't need a lot, but this causes the super glue to basically set up instantly, and we have ourselves a very nice 2-inch wooden cube. Let's make a cardboard or a chipboard cube. I have several other videos on this already. Cardboard basics, cardboard advanced basics. Basically, I'm measuring out the thickness of my cardboard or my chipboard, and I'm putting some tape on top of it. Notice how I stick it on my jacket first to make the tape not so aggressive. Now, this is important with the chipboard because the chipboard is pretty cheap and you want to have not a lot of adhesion on that chipboard. We're going to use the same online resource, the MakerCase website, and just adjust for the thickness of the material that we're using and lay out our box. We put it all together. Now, I'm going to use some white glue, and you saw me use the standard white glue bottle. It's not as good as one of these Lure Lock bottles with a blunt nose steel tip on it. I have a link for those below as well, because these Lure Lock bottles allow you to get the glue exactly where you want, and you really don't need that much to glue a piece of cardboard together. The cardboard is pretty absorbent and absorbs that glue instantly. So one of these Lure Lock bottles, much better than the standard white glue dispensing bottle. You really get some good control. We're going to put the ends onto this cardboard cube, and we're almost there. Yeah. We're going to put the side down that does have the burn marks on it on the inside of the box. Just a little trick there, because you won't see that. We want to have the nice side on the outside of the box. When you're cutting this chipboard on the laser, you want to make sure that you set the laser power at the absolute minimum that you need to cut through the material. Any more, all you're going to do is burn the edges, mess up the part. So you want to have just the right amount to where it just cuts through and nothing more. Gives you a nice, sharp, crisp, clean box. Watched any of the other videos on my channel, you know that I'm a big fan of foam core, and I have multiple videos on foam core basics and foam core advanced basics. We're going to basically make a foam core cube here. We don't need an online resource for that because we know we're going to make a 2-inch by 2-inch by 2-inch cube, and all the sides are going to be the same because we're going to bevel the edges. In this case, we're going to make this cube with a hole in the middle. This is something that would be pretty difficult to do by hand, but with the laser, piece of cake. You can get the software to line up that hole right in the middle of your part without very much difficulty. Once I have all the pieces cut out, I'm going to go through and bevel each of the edges at 45 degrees so that I can fold up the sides of the box to create my cube. And you all know I hate hot glue, but in this case, hot glue is a nice material to use to glue the foam core together. It sets up quickly, it's thick, it fills up the space in between the 45s, and it works quite well. Make sure you have that piece of tape on the end to glue the box together. I use the cutting board to make the box nice and square. You could use your right angle square as well. We want to know the size of that circle to cut out. We know that it's a 30 millimeter diameter circle. That radius is 15. You go online, use the circumference of a circle to find out the dimension, and boom, you can build a box in your laser cutting software that is the exact size of the inside circumference of that hole. I'm going to make a little test one just to test things out, make sure that I can put the thing together, and I use a regular piece of paper and a piece of tape. I leave a little bit of a space on the end of my tape so it doesn't come quite to the edge of the paper, so that I don't have any weirdness on the foam core. This is just my little test piece. I slide it inside the hole here. You need that overlap of the tape so that you get a good transition from one surface to the other. The hardest part of this whole box is probably just getting this little paper tube inside the hole. Now I make a final paper cone or cylinder out of a thicker paper. That was just a test before. So this is a little bit more durable, not as translucent, and I glue that onto one end of the box with the hole in it, and we're going to attach the other end to the existing cube so that we can put it all together and have this nice hole going right through our cube. All right, on the other end, I'm going to use white glue. And you ask, well, why use white glue? I am going to need some time to get that paper tube into the hole on the other side, and the hot glue is probably going to set up before I'm able to do that. The white glue is going to give me some working time. And here I'm using an x-acto blade to get that paper tube inside the hole of the foam core. There we go, we're almost there. Boom, drops down, and eventually that white glue will dry. As you know, white glue gives me great strength. It works fantastic. There you go, cube with a hole in it. Something you could probably pretty much only do with a laser. Next video, advanced laser techniques. We're going to cover all kinds of other shapes and advanced cutting techniques on the laser. Stay tuned for that. Make sure you give the video a thumbs up, and don't forget to subscribe if you haven't already done so. Hey, and don't forget to follow me on social media. I'm on Facebook sometimes, Twitter usually, and now Instagram. Rock on. Click here to check out some of the other design and making videos that I have that you might enjoy.